Hey guys, I'm Mike McDonald. Let's talk standards. Standards would allow different organizations to develop or deploy technologies and solutions and be sure that they can play together nicely with other organizations. And it's the foundation of mobile networks and the internet in general. 5G is the fifth generation of mobile technology as defined by the 3GPP and ITU standards processes. Okay, great. But who are the 3GPP and ITU? It's actually a very complicated relationship between the third generation partnership project and the International Telecommunications Union. So let's back up a little bit. There are four main groups that make up the telecommunications world. First, we have the vendors. These are the guys that put millions and billions into R&D to develop the next generation of cool products. Second, we have the operators, or in our case, telecommunication operators, or telecom operators, or even telcos, that buy the equipment from the vendors, build networks, and sell the service back to us, the users or consumers. And then we have the standards organizations to make sure that we all play nice. Imagine how much easier global business would be if we all spoke the same language. Well, that's kind of like the goal of standards organizations. They try to define a set of rules or processes that vendors and operators should follow so that when they start investing their dollars in development, or in our case, learning a new language, the final product works with other vendors' equipment. In other words, we can all speak the same language after we've locked ourselves away for a year of study. Of course, there may be vendors or operators that want to add their special sauce, but these are more like cool regional dialects or funky words. You don't need them to understand the core language, but they might get you in with the cool kids. In fact, a lot of these extra ingredients often become proposals for the next standards. The ITU is an intergovernmental organization under the United Nations that manages global telecommunication affairs with the goal of connecting all of the world's people. Specifically, the ITU-R, or the radio communication arm of the ITU, covers the overall radio aspects of 3G, or IMT 2000, 4G, IMT Advanced, and 5G, IMT 2020, and future generations of wireless mobile telecommunications technology. The 3GPP is a consortium of telecom players, and according to Wikipedia, it's an umbrella for a number of standards organizations which develop protocols for mobile telecommunications. This includes UMTS, or Universal Mobile Telecommunication Systems, and all the related 3G standards, including HSPA, which is High-Speed Packet Access, and HSPA+. It also includes LTE, or Long-Term Evolution, and all the related 4G standards, including LTE Advanced and LTE Advanced Pro. And of course, 5G, including 5G New Radio and related 5G standards. Note to self, don't name an organization after technology with a finite lifespan. This might sound complicated, but each technology is typically a bandwidth or a functional enhancement of the previous generation. In fact, operators are so well aware of how confusing these names are that they typically go to market with 2G, 2.5G, 2.75G, 3G, 3.5G, 3.75G, 3.95G, 4G, and so on. Until the advent of IMT 2000, the third generation system for mobile communications defined by the ITU-R, cellular networks had been developed under a number of proprietary regional and national standards, creating a fragmented market. First generation networks deployed in 1979 and throughout the 80s delivered analog voice and included Advanced Mobile Phone System, or AMPS, first launched in the US, Nordic Mobile Telephone, or NMT, developed by the Nordic countries, and Total Access Communications System, or TACS, which was based on AMPS technology but first used in the UK. Second generation networks deployed in 1991 and throughout the 90s introduced digital cellular service and were defined predominantly by two groups, known as the European Telecommunications Standards Institute, or ETSI in Europe. Those are the guys that gave us Global System for Mobile, or more commonly GSM, and the Telecommunications Industry Association, or TIA, in North America, the guys that gave us IS-95, or more commonly CDMA-1. Up until this point, anyone having a mobile phone and traveling internationally would have felt the pain of having multiple organizations defining 1G and 2G systems. CDMA-1 phones didn't work on GSM networks, and unsurprisingly, GSM phones didn't work on CDMA-1 networks. The concept for IMT 2000 International Mobile Telecommunications, as the third generation system for mobile communications happened in the mid-1980s at the ITU, with a fundamental goal to provide universal coverage and to enable seamless roaming between multiple networks with speeds of 2 megabits per second for fixed stations and 384 kilobits per second for mobile stations. Interesting bit of trivia, the 2000 refers to 2 megabits per second, or 2000 kilobits per second, and not the year it was deployed or conceived. IMT standards are not specific technologies. Instead, they are specifications and requirements for high-speed mobile broadband service, taking into account what technology is expected to provide within a corresponding time frame. The 3GPP came pretty late to the game in December of 1998, with the mission to unite telecommunications standard development organizations like ETSI and TIA and provide a stable environment to produce reports and specifications that define future cellular mobile technologies. These releases are more feature-specific and they're designed to align with the commercial needs of operators and vendors, but they also meet the more general specifications of the ITU. Given the significant divide between CDMA1 and GSM, the 3GPP actually created a sister organization called the 3GPP2 to define a backwards compatible successor to CDMA1 called IS2000 or CDMA2000. For the rest of the world, the 3GPP defined a whole new architecture unrelated to GSM and using CDMA called Universal Mobile Telecommunication Service, or UMTS. After a lot of hard work, the unanimous approval of the technical specifications for third-generation systems under the brand IMT2000 was made in, ironically, 2000. This included full support within the ITU and externally with entities including the 3GPP and the 3GPP2, with UMTS and CDMA 2000 both meeting the requirements of IMT 2000, or 3G. Subsequent standards for 4G and 5G are more broadly defined by the ITUR as IMT Advanced and IMT 2020. IMT Advanced defines 4G as an all-IP network supporting 1 gigabit per second for fixed stations and 100 megabits per second for mobile stations. IMT 2020 defines 5G segmented into 3 usage scenarios. First is Enhanced Mobile Broadband, or EMBB, which must deliver 20 gigabits per second peak downlink and 100 megabits per second per user 95% of the time. Second is Massive Machine Type Communications, or MMTC, for connecting IoT devices with densities as high as 1 million devices per square kilometer. And third is Ultra-Reliable Low Latency Communication, or URLLC, which must provide 1 millisecond latency for enterprise-grade applications in vertical markets like manufacturing, logistics, finance, healthcare, and more. Just like what we're used to with software releases, the 3GPP uses a system of parallel releases to provide developers with a stable platform for the implementation of features at a given point, and then allow for the addition of new functionality in subsequent releases. For example, the initial 3GPP architecture for UMTS was defined in Release 99, with the introduction of a split between the control and the user plane on the core network in Release 4. Yeah, I know, they skipped a few numbers, or reset the numbers, but trust me, the rest makes sense. HSPA and HSPA Plus were releases 5 through 7 and focused on improving uplink and downlink capacity. LTE was introduced in Release 8, with the actual 4G specification of IMT Advanced being reached by LTE Advanced in Release 10. Yes, that's right. The first release of LTE was not a 4G technology. Releases 11 through 14 introduced bandwidth enhancements to LTE, like 4-band carrier aggregation and interband carrier aggregation, and also added narrowband IoT and machine-type communication to allow for things to connect to the network at scale. 5G, or IMT 2020, was first defined in Release 15 with a new higher efficiency air interface called 5G New Radio, for lack of imagination, I suppose, and 2 methods of deployment, including 5G non-standalone, where 5G New Radio is deployed using a 4G core network, and standalone, where 5G New Radio is deployed with a 5G core network. Yes, that's right. The new air interface defined in Release 15 can be deployed with a 4G network to add bandwidth while relying on 4G core network for control. Release 16 introduces 2 more fundamental concepts to Release 15. The initial 5G release focused mostly on enhanced mobile broadband, or really big gobs of bandwidth, by introducing new bands like the C-band and the millimeter wave band, which is 28 gigahertz and above. It also introduced massive machine type communications for connecting the Internet of Things. Release 16 introduces ultra-reliable, low-latency communication for services like robotics and self-driving cars and other vertical applications. And it improves on the MMTC with industrial IoT capabilities. 5G is the first technology defined out of the gate to support more than just smartphones and laptops and human-to-human communications. It is the foundation for the Internet of Things and ultimately the new digital economy. So, for the foreseeable future, the 3GPP and the ITUR will continue to define mobile cellular technology standards, with the general requirements defined by the ITUR under IMT, like IMT 2000, IMT Advanced, and IMT 2020, representing 3G, 4G, 5G, and specific feature details defined by the 3GPP release process, which are more like interim technologies within 3G, 4G, and 5G. And why do we do all of this? Well, it's simple, so that you can watch these videos anywhere in the world. Thanks for joining. See you in the future.